Here, in last video, we studied about what is hierarchical clustering, what is agglomerative, what is single link, complete link, and the difference between single link and complete link. About that. Now we are going to see about what's criterion. What's criterion? What's criterion was proposed to compute the distance between two clusters during agglomerative clustering. This process of using Watt's criterion for cluster merging in agglomerative clustering is also called as Watt's agglomerism. It uses the K-mean squared error criterion to determine the distance for any two clusters CA and CB. The Watt's criterion is calculated by measuring the distance in the value of the SSE criterion for the clustering obtained by merging into CA universal CB. The Watt's criterion is defined as the velocity, defined how it is. W of CA universal CB, CA universal CB minus W is equal to NA divided by NN plus CAU minus CA C bottom B, or B equal to B of NA plus B equal to 1 D C comma C divided by NA plus NB AB. It is the equation of Watt's criteria. So the Watt's criteria can be interpreted as the square equilibrium distance between the centroids of the merged cluster CA and CB varied by a factor that is proportional to the product of cardinalities of the merged clusters. It is Watt's criteria. It is a formula and equation of Watt's criteria. Next, agglomerative hierarchical clustering algorithm. In agglomerative algorithm, provide a basic outline of an agglomerative hierarchical clustering. The dissimilarity matrix is computed for all the points in the data set. The closest pairs of clusters are repeatedly merged in a bottom-up fashion, and the dissimilarity matrix is updated. The rows and columns pertaining to the old clusters are removed from the dissimilarity matrix and are added for the new cluster. Subsequently, merging operations are carried out with this updated dissimilarity matrix. Here, the line fifth step indicates a termination condition for the algorithm. The algorithm of agglomerative hierarchical clustering is 1. Compute the dissimilarity matrix between all the points. We have to compute the dissimilarity matrix. I already in previous video we already see what is dissimilarity. And we see all the figure for dissimilarity matrix. Second, repeat the same process until it compute. Merge clusters as it is the formula of Warren's criteria. We seen this in previous slide. Merge clusters as C A universal B equal to C A universal CB. Set new clusters cardinality as n of n bottom A universal B equal to n A plus NB. Insert a new row and column containing the distance between the new cluster CA universal B and the remaining clusters. Fifth line, important. Until only one maximum cluster remains, you need to insert a new row and column containing the distance between the new cluster CA universal B and the remaining cluster until the maximal cluster remains. Next, let's see the values of coefficient for the Lance-Williams dissimilarity. In next slide or upcoming slide, where we will see Lance-Williams. What is Lance-Williams dissimilarity? For the Lance-Williams dissimilarity update formula for different hierarchical clustering. Here, there was a name. What are the dissimilarity in Lance? Methods of names of the method. Lance-Williams dissimilarity update formula. Single link I equal to 0.5, 0 minus 0.5. Completely. Delta equal to 0.5, 0 minus 0.5. GAAC. I plus J is equal to 0. Delta equal to 0. Center. Delta is equal to delta I plus J. Delta I plus into J. And delta is equal to 0. What's delta is equal to delta I plus delta J plus delta K. Delta is equal to delta minus I plus J plus K, and delta is equal to 0. These are the coefficients for Lance-Williams dissimilarity updated formula for different hierarchical clustering algorithm. Next, later in this also see Lance-Williams dissimilarity formula, updated formula. We are discussing many different proximity measures that are used in agglomerative hierarchical clustering. A convenient formation in terms of dissimilarity which embraces all the hierarchical methods mentioned so far is the Lance-Williams dissimilarity update formula. If points I and J are agglomerated into clusters I union J, and they will have to specify just the new dissimilarity. Values of the coefficients for the Lance-Williams dissimilarity update formula. In this box, sorry, I only copied this. When we see this slide, we see this table in previous slide also. Sorry, this is my mistake of copying. Here, between the cluster of all other points, the formula is given as follows. D I union J, comma K equal to delta I D I comma K plus delta J, D J comma K plus delta D I J plus delta modulus D comma D of I comma K minus D of J comma K. Here delta I, delta J, and delta define the agglomerative criteria. The coefficient values of the different kinds of methods are, we studied this box. Next, divisive clustering. Next is divisive clustering. We already see agglomerative. What is agglomerative? Divisive clustering. Divisive hierarchical clustering is a top-bottom approach where the procedure starts as the root with all the data points and recursively splits it to build a dendrogram. This method has the advantage of being more efficient compared to agglomerative clustering, especially when there is no need to generate a complete hierarchy all the way down to the individual leaves. It can be considered as global approach since it contains the complete information above before splitting the data. Issues in divisive clustering. We will now discuss the factors that affect the performance of the divisive hierarchical clustering. Splitting criteria. The Watts k-mean square error criteria is used here. The greater reduction to obtain in the difference in the SSE criteria should reflect the goodness of the split. Since the SSE criteria cannot be applied to numerical data, only Gini index, which is widely used in decision tree construction in classification, can be handled for this. Splitting method. The splitting method used to obtain the binary split of the parent node is also critical since it can reduce the time taken for evaluating the Watts criterion. The bisecting k-means approach can be used here, k is equal to obtain good splits since it is based on the same criteria of maximizing the vast distance between the splits. Choosing the clusters to split. The size of cluster chosen to split may not be as important as the first two factors, but it can be still useful to choose the most appropriate cluster to further split when the goal is to build a compact dendrogram. A simple method of choosing the cluster to be split further would be done by merely checking the square root errors of the clusters and splitting the one with the largest value. Handling noise. Since the noise points present in the dataset might result in the aberrant cluster, a threshold can be used to determine the termination criteria rather splitting the clusters further. This is issues factors affecting the performance of the visual clustering. Thank you.